All right, guys. So, happy Friday. It's 3:33 in the afternoon, and I'm about to record a podcast to help you get through some of the calculations on gas laws that we've given you this week. So I'm gonna come up with one here, and then I'm gonna record a separate video for another calculation. What we're looking at here is the equation for Boyle's law. And Boyle's law basically states, as you've learned this week, that as the pressure of a gas increases, its volume must decrease as long as you're holding it at constant temperature. And the equation for that is right here in the middle of the screen. P1 times V1 equals P2 times V2. Now, basically, P1 and V1 are what we would call the initial conditions before we do anything to it, and P2 and V2 are the final conditions. So what we're going to do here, we're going to assume that the temperature is constant, and we're going to change something. And generally what we want to know is what is going to happen to the other quantity when we do that. So in this case, this is exactly the problem that we had on this week's assignment, the gas laws intro. And we're going to solve this equation for V2. So what we're saying here is that basically we're changing the pressure. And we want to know what happens to the volume when we change that pressure. Sorry if you can hear my dogs in the background. They're a little restless. So what we're going to do is when we talk about solving for a variable in an algebraic equation, we're talking about getting that variable by itself. So we want to make sure that V2 is by itself on this side of the equation and that everything else goes to the left side of the equation. I just pointed over there and realized that you can't see me pointing. But what we're going to do is we're going to attempt to remove P2, this right here, from this side of the equation, from the right, and bring it over to the left. Now, the rule in algebra, when you want to do something to get rid of a variable on one side of the equation, you're going to do the opposite thing that is actually in the equation. Let me explain that a little better. So here we're multiplying. We're multiplying the pressure times the volume on both sides. And so since we're multiplying pressure times volume, we're going to want to divide both sides by that pressure to get it on the other side. So the way this is going to look is that we are going to divide both sides by P2. Now that is going to leave V2 all by its lonesome on that side, which you'll see in a minute. So we'll take both sides and divide by P2. And then on the right side of the equation over here, we notice that since P2 appears on the top and the bottom of the fraction, we can cross that out. So we eliminate it. So what we end up with is V2 is equal to P1 times V1 divided by P2. So if we were to plug numbers in here, I'm just going to create a hypothetical situation here. Let's say that the initial pressure is 2 and that the initial volume is also 2. Let's just throw out some numbers here. Let's say that we change the pressure, P2, to, let's say, 4. And we want to know what V2 equals. Incidentally, in this weird time we're in, I think I hear a teacher parade happening outside my house in Nashua. So let's plug in these numbers and see what it's going to look like. So V2, I just kind of gave away the answer here. I was doing some quick mental math. So V2 is equal to P1, which is 2, times V1, which is also 2, divided by P2, which in this case is 4. So 2 times 2 is 4, divided by 4 gives us 1. So that kind of gives you a numerical idea of the sort of math we're going to do here, but we're not gonna spend too much time on the nitty-gritty math of things. I just wanted you to kind of think about how we would solve for a given variable if we knew a lot about the others. So hopefully this is helpful. Feel free to show your friends. Feel free to tell people in other classes. Faster this spreads around, the more people get help, the better off we're going to be. So have a great weekend. Bye.